In this video, I will be discussing the basic looping concepts in the 8085 microprocessor. So let's get started.
Taking a look at the microprocessor, which is a multi-purpose programmable register-based electronic device, we will use the GNU SIM 8085 for carrying out simulations.
Firstly, we understand the basic theory for looping. Looping is a programming technique which tells the system being programmed that a set of instructions or tasks has to be repeated. There are two types of loops: continuous loops. These loops are also called infinite loops because they run continuously until the system is reset. That is, they have no ending condition. Conditional loops. In these loops, the number of iterations is limited by the condition which, when satisfied, causes the control to come out with the instructions provided in the loop. Looping in the 8085 is implemented using the jump instructions, that is, conditional and unconditional jumps. Next, we will be looking into the flow of loops using an example of a program to generate the Fibonacci sequence, where any number starting from the third number is the sum of the two preceding numbers. First, we load the initial address 0009 into the HL register pair. This location in the memory contains a user entered number, which is the number of terms to be generated. Next, we increase the HL pair and move the two starting digits into B and C registers respectively. Entering the body of the loop, we move the contents to A and that of A into the memory. Then adding A to C, we get the new term in A. Now we store C into B and overwrite C with the new term to be used later. Increasing the value of HL and decreasing D, we check whether D is 0. If not, the control remains within the loop, else the program terminates. Now we see how the data flows.
Initially, the HL pair contains 0009 while B and C contain 01 respectively. Copying the value into a accumulator leads the memory to contain first term 01. Now the value of HL is incremented. Because the value of B is copied into A and B is updated every time with C, which in turn contains the sum of the previous two numbers. The memory starting from the third term contains the Fibonacci sequence correctly.
Next, we consider an example of a program to find out whether an entered number is prime or not. Looping is employed for repeated division of the entered number by numbers ranging from 0 to the number. The data flow can be understood as follows. The accumulator stores the number entered, with C containing the number for reinitialization. B register stores the divisor in each step. If the number upon repeated subtraction leaves no remainder with the divisor other than itself, it is not prime.
Thank you.